Okay, so we'll proceed on solar system in the lab session. So we'll remove the airplane that we don't need now, and okay, so coordinate system will make it local. Okay, so pretty good. And here we don't need. Okay, so we are building the kind of solar system. Okay, so display is all right. This is also perfect. Okay, so this stuff we don't need now. Okay, so it is for loop. So this is inside the for loop. So everything should be okay. This. Okay, so we still will use GL perspective, and keyboard and everything is all right. Okay, so we'll introduce a function. So we are here, and so before we introduce, so I have a file called kind of ss.json, and it talks about the kind of a dimension, or you can say kind of a geography or architecture or layout of solar system. So sun has radius, color, and it has child as earth, and earth has child as moon, and all the features. So we will read this file, and after reading this we'll draw this. So that is the idea. Okay, so I'll say def draw, and that is the code. So it is shape hash. Okay, so it's a kind of a recursive function. So it would kind of the way children, one contains children and like that. So it would recurse in that manner. Def str to tuple str. So I have a kind of a quick function, kind of utility function. It receives a string and return the tuple. So tuple of float I for I in RE find all or plus tuple string. Okay, so this is the code. Okay, so we'll have a global begin time so that we can kind of start rotating. That is the idea. So GL push matrix if rotation in shape hash GL rotate F Okay, so GL rotate f time dot time minus begin time. So whatever the time that is kind of over, shape hash rotation shape hash rotation into 360. Okay, now what is the rotation? So we can say kind of str to tuple and shape hash rotation axis. Okay, so whatever time is over minus the begin time, and it is kind of modulo shape hash and rotation divided by shape hash rotation into 360. So this much it has rotated, and then str to tuple shape hash rotation axis str to tuple is over. I believe it will be 2 only. We'll see. GL translate str to tuple shape hash distance if distance is available in shape hash, else none. If rotate on axis like earth, it rotates on its own axis. If rotate on axis in shape hash GL push matrix GL rotate. Okay, so kind of we can just copy what we have done. GL rotate. Okay, so instead of str to tuple, so it is a kind of fix, that is 0 1 0. Okay, I think that's it. Okay, GL color 3F str to tuple shape hash color. Okay, so that is the concept for the color. Okay, we'll draw glut solid sphere shape hash radius 40 and 32 GL pop matrix. Okay, so where we are. Okay, so if it rotate on its own axis, Okay, so this is Python and we have must take care. So if rotate, okay, so it should come under if rotation in shape hash, then we rotate, translate if it rotate on own axis. Push matrix, rotate again, color, draw, pop matrix. Otherwise, just draw it. Okay. So I think we can copy paste. So color and radius and 42. It's a pretty simple code. Okay. So if that is not the case in the sense, so if is this, if there is no rotation in the kind of sun has no rotation, then we can just say okay, color, place the color and uh, then we can just draw it, GL solid color, glut. So I think okay. Otherwise, now, so this is recursive function. So we can just call it shape hash child if I in child in shape hash and shape hash child or yes. Okay, so child in shape hash, if that is the case, then iterate to the child or just don't call the draw again. Pop matrix. Okay, so this is the code. So this is a string to tuple. If someone passes the string, it tries to find out all minus or it is a numeric or anything, and then it returns I and float I a tuple. Okay, begin time we'll see. Now it pushes the matrix. If rotation in the shape hash, it rotates. Fine. Now time whatever the current time minus begin time percent the shape hash notation. Okay. Okay. And so this is closed. So this gives the kind of the remainder, and then we divide by the shape hash rotation. Okay. And multiplied by 360, and then we whatever we receive the rotation axis, on which axis it rotates, so that axis. Now we rotate first and then we translate as per the kind of local axis fundamental that we have described. So translate is distance. Okay. If distance in shape hash, otherwise nothing. If it rotates on its own axis, Then push a matrix again and same story. Here it would be rotate on axis, rotate on axis, rotate on axis. Okay, now it will take the color and it will draw as per the radius pop. If it doesn't rotate, then just color and draw. If that is not the case, because if there is a rotation found, then there is a kind of rotation and translation. If nothing is there, then just draw. If nothing is there, then just draw. Now call the draw shape as child I for I in the child and done. So this is a kind of a recursive function, and recursively it draws all the shapes. Okay. Now supporting this recursion, will add the other thing, like now we will import JSON, we import time. So these things we import. Down the line we have begin time equal to time.time, JSON shape dict equal to JSON.load, read ss.json, this is the file. Okay. So in it we have, so we have disabled lighting right now. So only other parts are there. Okay. So begin time, that we have taken care. Now we'll come to display and we'll say global JSON shape dict. Okay, so this is the global shape. And here when we are doing the kind of shape drawing, so we'll just call draw JSON shape dict and sun. Okay, so that's it. This is the modification we need, and we don't need any other modification. Okay, so we'll call glut timer func every kind of 0.1 second, and it would call this function itself and pass 10. So it needs a third parameter. So we'll add a third parameter. So we'll call something like value equal to none. So this is the kind of timer idea, and keyboard nothing would change. Okay. We'll open ss.json, and we need a kind of distance, color, rotation on its own axis. Okay, distance, color. So rotation axis moon is 001. Rotation on axis. So rotation axis will add. Now rotation axis is required. Rotation axis. So Earth would rotate on kind of across y-axis. So rotation axis of the Earth is y-axis, where rotation axis of Moon is z-axis. This is what we are seeing. So we can just execute this. Okay, it's not matching. So draw shape if child in okay. So I think it should match now. Draw shape for I in okay. So read is not defined. Okay, I don't want read. Okay, it is open. Oh, it's visible. We can see now that Earth is rotating across Sun. I mean, I can kind of make it like this. So it is rotating on XZ plane. So Earth is rotating across. I think it would be better. So this is ortho GL perspective. We can make it ortho. So Earth is rotating. So what idea here is that Earth is rotating kind of across y-axis, whereas Moon is rotating across z-axis. So I can. This is too quick. So Earth speed I can kind of decrease 8 t, and I'll make it as a kind of GL ortho I can enable. Okay, so to make it clear, I think I can change more. So Earth is 1.5, that is kind of touching the scenario. So I'll make it 1.4. So that looks better. And okay. Okay, so this is the scenario, or make it smaller. It should be visible. Okay, so X, Y, and Z axis are visible, and Earth is moving on X axis, XZ plane along around Y axis, whereas Moon is moving around Earth, and it is moving orthogonal. The way Earth is moving, so Moon is moving orthogonal. Okay, so this is the reality, means this is the way kind of Moon moves. So Moon is a kind of it is orthogonal. Okay, Earth is rotating on its own axis, but since we have used a circle and same color, so in texturing we will see, once we put the texture on the Earth, then it would be visible that it is rotating on its own axis. So this is the kind of a scenario. Now we are free to add kind of one more kind of mm, okay, so kind of a mercury. So here we'll have mercury. And what is the attribute of mercury? So I think we can copy paste 2, 3, 4, 3, 4, 5, 6. So mercury would end here and there would be a comma. JSON is very strict in this comma and curly braces and so and so. So how big is mercury? So we can say it is not very big, kind of 0.09. And what would be its distance? So I can say 0.6. Okay. What would be its color? So it's certainly not blue. So I can say kind of 0.5 and 0.3 and 0.3 and rotate on its own axis, so that we don't need at all. And rotation, so how many days it takes, so we can put kind of 40. Rotation axis, along which axis it is rotating. And distance, so distance is where it is, so we can make it even kind of more interesting. So we can say kind of so I have made x, so I can make like distance as in y direction x, so distance is same 0.6 but in y direction. And rotation axis, so we can say kind of 1 and 0 and -1. So 1, 0, -1 means there is a line in xz plane, and we can imagine where the line is in xz plane. It is at 45 degree, and so it is a distance in y direction. So this should be orthogonal, means that is the idea. Okay, I think we are done. 0.5, 0.03, 0.03 color, and distance is this. So we'll try. There is no harm in trying. Oh, so Mr. Mercury has come. This way we can make a kind of a complete solar system. So Mercury is not a kind of, it is moving the way Earth is moving. That is the catch. Earth is moving across y-axis, whereas Mercury is moving across a line that is 45 degree angle, and that is on lies on xz axis. So it's different. Okay, so this is the fundamental. We can rotate even y more. We can see the how these are moving. So just we need to add in the JSON file, and it would draw the way we are thinking. Okay, so now concept is that we will add lighting to this code, so there would be light. That is the idea. Okay, so we will kind of here we will enable the lighting. Okay, so there is no shame in enabling the lighting. So these two lines would enable the lighting. That's it. Now we'll place the light source where Mr. light would lie. So light source, I think best plate would be here only. We'll place the light source. Okay, so we'll say GL light FV GL light 0, GL position, and that is 0, 0, 0, and it is positional light because Mr. Sun is the source of light. So this is the positional light. Okay. Light should be kind of good intensity, so we'll add GL light 0, GL diffuse as kind of 2, 1.0. So light would be nice, means I am making it bigger. That's it. Now instead of color, now we have color. So instead of color, it would be it would be kind of material, GL material. So okay, so here now we have color, GL color, GL color. So now color would be replaced by GL material. So we can just comment it and we'll say GL material FV GL front GL what is diffuse color. Okay, so whatever color we are receiving, same color. Okay, and we'll add 1.0. So this is Python. Means the way we talk, same way we can write code. There is no difference in talking and writing the code. So amazing. Okay, so we'll place here also. So GL color has no meaning now. And we'll place here also. There is no meaning of color. Okay, now here there is a catch kind of okay, so here a kind of GL material we diffuse, we don't want in sun because sun should glow on its own. Okay, so we'll make kind of a GL front diffuse as 0, we don't want, and here we'll add GL material FV and that is GL front GL emission, it has its own emission. Okay, and what is the emission? Color. So it is same. I believe I can copy this GL front and it is emission, and emission color is same thing what we see. Now once this is drawn, okay, so we'll set emission as 0. It should not kind of hamper others. Okay, so GL diffuse 0, 0, 0 means it is not receiving any light because it would be multiplied by 0, 0, 0. So whatever diffuse color is coming, it has no meaning here. and then we are setting the emission. It should kind of emit its own light, and we are setting emission back to 0. So that is the code. Okay, so that is, and the axis what we are drawing. So axis color is also gone, and in axis color we would set a diffuse and emission. So diffuse would be 0. So I believe I can just copy this and I'll go to this place, and Mr. Color is gone. So I can place it here. Mr. Color is gone. Material GL front diffuse 0 and GL material FV GL front and GL. So this line would emit its own color. Okay, emission, and whatever it is, same thing, we'll add 1.0. Okay, okay, so it is done. So the line we are drawing, so no coloring now, coloring fundamentals are over, and GL material diffuse we are setting as 0, and then emission we are setting. Okay, so it's a good idea that once it is done, then emission we can set back. Okay, so once it is for loop, emission back to 0. Okay, but anyway, when sun is drawn, anyway it will be set to 0, but it's okay, means no problem, means we can set it. Okay, so I think we are done. Line width, I believe it is not showing very well, so we can make it 2, so it will be thicker, or we'll leave it as 1 only. Okay, so GL material diffuse, and then I1 and 10, then material emission, and here we have set same thing. Otherwise, other places color is gone, and material FB front diffuse, and one more place here and here. Okay, so let's try our luck in the lighting model also. Oh, it's working. Now we can see the lighting model, means earth is only the face that is facing is it has light, otherwise there is no light. Okay, now Mercury is also kind of where it is showing the light. We can rotate more. So this is how Mercury is rotating in different fashion than the Earth is rotating. Okay, I think Earth moon distance should be less. It should be near to the Earth, and Earth will make. So this is how we can build solar system. So I'll demonstrate little bit the draw function again. So draw is a recursive function, and every time it receives a hash, and if there is a rotation in the hash, then we think it is a kind of a planet, and we rotate as per the fundamental, we translate, and then if it rotating on its own axis, then we push the matrix and rotate it again, come back in the pop, otherwise we draw it. So then before it pops, before it does GL pop, we call the function again. So this way its child, whatever its child is, it is getting kind of translation, and so its transformation, whatever it is doing in the context of the parent. So one parent is done, then GL pop is called. Okay. So if moon is there, for moon there is no child, pop will happen. It will come in earth, and again pop will happen. So that way it works. So I believe we are not happy with the JSON. So earth is okay, distance is still too far, so we'll say 3. And Mr. Moon, distance is 3 from the earth. Okay, so we'll make it 2 from the earth, and we'll try again. Okay, so we'll make it bigger, and we'll now we can see the kind of XYZ. So red is x-axis, blue is z-axis, and y is y-axis. Small portion is negative and bigger portion is positive. Okay, it would be more fascinating once we put texture on it. So earth is rotating on its own axis, that should be visible when texture comes. Okay, this is the positional light. So we can see kind of other side of earth is black, that is ambience, and same on the Mercury side also. So if we follow the JSON file, then we can kind of keep adding planet and its satellites. So this would draw like that. Okay. So idea is that these shapes, right now we are using solid, it's a solid sphere. So this would change in a fashion called as we receive the object file, and it would not be sphere. It is as per the object file for the planet and its satellite. So it would change in that fashion, putting texture, then rotating on its own axis. That would be even visible more. So we can rotate axis and we can see where we are. Y will keep as vertical only, and okay, so Y is rotating. So we'll rotate Y across Y, and we see the kind of current scenario. So sun is glowing. There is no shadow in sun. So if I rotate Y, sun is also rotating, but there is no shadow. Whereas Mercury and Earth has shadow because light source is inside the sun. So this way they are seeing the shadow. Okay, so we covered solar system. We have anyway covered the viewport. Okay, so in that we saw the example of airplane. Okay, so in theory part we saw the kind of very interesting the pipeline and kind of grand coordinate system and grand fixed coordinate system and local coordinate system. So whatever we are following as we saw in the code, so I should abort it. Okay, and it is a kind of fixed, that is global, that is coordinate system is local, so that we have fixed. Same thing we can run on perspective mode also. There is no much difference. Only thing is If it goes far, then it would be smaller. So this is perspective mode, and we saw in kind of ortho mode that was kind of spanning across the screen. Okay, so this is solar system. I can rotate Y and sun has no shadow that we can see. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.